Hi everyone, section 0.5 is on exponents and radicals, and we're going to start by reviewing radicals. All right, so if you see this, you should read this as the principal square root of 9. And if you were asked to evaluate this, how do you simplify this? What is this? It is 3, positive 3. And why is it positive 3? Because 3 has the property that when you square it, you get 9. 3 is the principal square root of 9 because when you square 3, you get 9. But now wait a minute. There's another number with the property that if you square it, you get 9. What other number? If you square negative 3, you also get 9. So you could say that both 3 and negative 3 are square roots of 9. In fact, I'll say that right here. Both Both 3 and negative 3 are square roots of 9, but our favorite one, Ivanka, as opposed to Eric, our favorite square root is the principal square root, which is the positive 3, the non-negative root. So when you see this radical sign, we're looking for our favorite root, which is preferably non-negative. So the principal square root of 9 is 3, the non-negative square root, as opposed to the negative 3. All right. That's in my notes in this comment here. All right. The principal square root of 9 is 3. All right. We also say that the principal square root of 9 can be written as 9 to the 1/2. Either way, it's 3, because 3 squared is 9, so 3 is a square root of 9. But because 3 is non-negative, it's our favorite square root. 9 has 2 square roots, 3 and negative 3, but we take the non-negative square root, positive 3, as our principal square root. It's our favorite square root. By the way, why can we write the square root of 9 as 9 to the 1/2? That bears some explaining. All right, so if you take the square root of, I'll go red again. If you take the square root of 9 and you square it, if you take the square of the square root of a non-negative real number, you get that number back. The square of the square root of 9 is 9. Well, likewise, if you take 9 to the 1/2 and square that, now we're going to review rules of exponents later on, very soon, but you might remember that when you raise a power to a power or exponent, you multiply the exponents. You keep the base, 9, 1/2 times 2 is 1, 9 to the first is 9. So it does make sense that the principal square root of 9 can be written as 9 to the 1/2. By the way, if you have the square root of negative 1, that's not real. That's not real. It's I. Later on, we're going to call it I, okay, in chapter 2. But for right now, this is not real. Negative 1 has no real square roots. I'll write that. Negative 1 has no real square roots. Negative 1 is not real. Negative 1 has no real square roots. Okay. By the way, I might abbreviate square roots, like if I'm chatting with people, SQRT. So in a chat, I might use SQRT as an abbreviation for square root. Okay, going back to the notes here. So this here is called a radical symbol. And this in general is a radical expression. Now, the n here is the index. Put that in green. N is the index. X, which is the insides of that radical. X is the radicand. That's what you're taking the root of. So this is the nth root of x. It's the nth principal root of x. N is the index, x is the radicand. The radicand, sorry, it's the radicand. Now, if you have a square root, then n equals 2, and it's implied. So if the index is 2, we don't have to put the 2 there. We just write the square root of x. We don't have to put the little 2 there. That's assumed. That's implied. Again, the square root of x is also written as x to the 1/2. If x is non-negative, we're assuming that x is non-negative. If x is negative, we're dead. This expression will not be real. We're dead for now. For example, the square root of -1 is I. That's not real. Okay. The square root of 0 is 0. For some reason, people forget that. The square root of 0 is 0. 0 squared is 0. All right. Now, again, the nth root of x, also written as x to the 1/n, right? So, for example, the 4th root of 16 can be written as 16 to the 1/4. Okay? It's the principal nth root of x. Here, we have the principal 4th root of 16. Now, again, if the index, here it's 4, if the index is even, then the radicand better be non-negative in value. Otherwise, you're in trouble. If the index is odd, then we have more liberality. Then it's okay for this to be negative. All right. So why is the principal 4th root of 16, or 16 to the 1/4, why is that equal to 2? Well, because 2 to the 4th is 16, and 2 is non-negative. It's our favorite 4th root. See, later on in chapter 6, we're going to see that 16 has 4 complex 4th roots. I'm going to write that out. 16 has 4 complex 4th roots. Okay. But only 2 of them are real. The positive 2 and the negative 2. 16 has only 2 real 4th roots, 2 and -2. And our favorite one is, of course, the non-negative root. 2 is the principal 4th root of 16. It's our favorite root. It's real, and it's non-negative also. The -2 is our second favorite because it's at least real. Right. But wait a minute. What if we have an odd root and a negative number in here? Okay. The cube root of -8 is -2. That does work out. Okay. If you don't see that, let's do another example. All right. Okay, let's see here. What is the cube root of -1? The cube root of -1. Well, the cube of what real number is -1? There's only one real number whose cube is -1. His name is -1. So the principal cube root of -1 is -1. -1 has 3 complex cube roots, but only one of them is real, the -1. And it's the best we can do, right? Because positive 1 won't work. So what's our favorite cube root for -1? Well, it's the real one. -1 is the only real root for -1. Right? -1 is the only real 3rd root of -1. So it is the principal 3rd or cube root of -1. Because no positive number has the property that the cube is -1, the best we can do is this negative number, which at the very least is a real number. -1 is the principal cube root of -1. So the principal root can be negative if you're taking the odd root of a negative number. Likewise, the cube root of -8 is -2. Okay, this is also written as -8 all to the 1/3. You need the parentheses here. Right? We get -2 because the cube of -2 is -8. All right, and -2, although it's negative, is at least a real number. So we can say the principal cube root of -8 is -2. A principal odd root of a negative real number is negative. -8 has 3 complex cube roots, but only one of them is real. Unfortunately, it's negative, but it's the best we can do. All right. X to the m over n can be rewritten in 2 ways. I'm assuming, by the way, that this is reduced. For example, they're not both even, which can be confusing. My footnotes have technical notes, and it gets very confusing if these are both even. This is an easier case where both are odd. You can rewrite this in 2 different ways, 2 different easy ways. You can take the nth root of x to the m. So you basically take the power first and then take the root, or you can take the root first, take the nth root of x, and then raise it to the mth power. Okay, I'm assuming that m and n are positive integers, and they're not both even, because that's kind of a weird case. My footnote discusses that. Don't worry about the footnotes. They're very technical details. So x to the 3/5 can be written in 2 easy ways. You can take x, cube it, and then take the 5th root, or you can take the 5th root of x first, and then cube the result. Which is easier? Well, it depends. All right. So that was a review of radicals. Later on, we're going to discuss laws of exponents and radicals. These are closely connected.